All right, so now we're going to learn about data structures. That sounds kind of intimidating. Data structures. But we're going to store data. And so I'm going to go back to Golang Playground. And this is where we'll do a little playing around with data structures. And scope, I didn't put my scope thing in. And then we also did blank identifier, so I need to copy that and just put that down there. Blank identifier, blank identifier. And now we're going to do data structures. Data structures. And there's three data structures. You know, first of all, there's just a variable. Holds something of some type. And I could be more specific with my language. Holds a value of some type. That's a variable. Right? And so that type, there are all these types. So we could hold a value of some type. And we've seen a variable holding numeric types and string types and Boolean types. Those are pretty straightforward. So just an example of that, Golang Playground, x equals 42. We have a variable holding a value of some type, x. That would not be available if this was in some other package other than main. It would not be available outside that package because it's lowercase, right? So there's a variable holding a value. What if and what is that? What is that? What type is that it's holding? Format printf. I could use format printing, and it tells me, hey, that is an int. What if I wanted to hold a whole bunch of ints? What's another meaning? Full number, 451, right? Fahrenheit 451. What if I wanted to hold a couple of ints? I need a new data structure. So I have a 42 int, and then I just want to do a new line after that. .42 int, 451 int. What if I want to hold both those ints in some type of data structure? Z, var z slice of int. It's a slice. It's how we hold a bunch of stuff. Okay? Z equal append zx. Format.print line z. Format.print f %t new line z. No new variables on left side. That needs to be equals. I tried to declare, here I'm declaring z as a slice of int. And then I said z, I'm declaring it. Wait, no, it's already been declared.
I gotta work on my
Oh, all right, Ruben. Watch the videos.
I will. Thanks.
Yeah, take care. Thanks for joining us.
Hey, Noel.
I run this. We'll pause it so we can say goodbye to Ruben. Now, and I have a slice that holds one value, and that's 42, and the type is a slice of int. That is the type. It's a slice right here. That's the type. It's a slice. That's how we store multiple values. I could add more stuff into it. So I appended x, now I'm going to append y. Now this data structure is holding 42 and 451. I printed out the data structure, I printed out its type. I could also print out entries in the data structure. What's at position 0? 42 is at position 0. What's at position 1? 451 is at position 1. So var z slice of int gave me a variable with the identifier z of this type, and I said z append to z this value. What if I tried to append a string to something that holds ints? Bam. You can't do that. Statically typed. Right? So I have to append ints to a slice of int. If I wanted to just create on the fly, you know, like nums, I could use a slice literal. Nums, slice of int, slice of int. And this is known as a slice literal, right? So there are, in the language spec, we have a struct literal, struct literals, composite literals. So these are composite literals. So we're talking about composite data types. Sometimes they're called aggregate data types. Compose, bring together, aggregate together, different values, right? And so we could have composite literals. This is a composite literal. And more specifically, we could say, you know, it's a slice literal, right? Because here the, you know, we just say slice event and then we do curly braces and pass in the values, and here's where it talks about whether or not how to do that. You know, it just talks about it there.
So, is there a reason why we had to tell it when we appended x into z, why we had to tell it to go to z? Because we already said z equals. Why did we again have to say to z put x?
Because you might be wanting to append to cowboy this slice, right? In which case, that cowboy would have to be something different. So the z's are not always the same. Like if I had var cowboy slice event, right? So this one, and then I could do now. Let's look at these.
Into the x. When you say append, you're just putting it into whatever the last position in the slice is?
Yeah.
Okay. So in z equals append zx, you put x, 42, into a position in z. And
right here.
Cowboy, you put...
We appended to z, which at this point is 42. It's a slice of ants with 42. We appended to a z, which is this, right? We appended y, which is this. So that gave us this. Because when we append 42 to z, z becomes an int holding 42. Slice of int holding 42. And then here, when we append to this slice, right, which is z, because here, right, this is what that becomes. That becomes z is now equal to a slice of int with 42 in it. That's what z is now equal to at that point. And so when we append to z, we're appending to a slice of int that has the value 42, and we're assigning that to Cowboy. So now Cowboy,
And a cowboy is a slice of 2 ends.
Cowboy, yeah, started out with 42 and added 451, appended 451. So,
can I ask a question?
Yeah.
You declared the variable z as being a slice of int. The z equals that z, that's the same z?
Yeah.
Okay.
So the slice of ends can be a member of another bigger slice of ends.
Yeah. Yeah, you could append slices to slices.
And call them a new set with a new name.
Uh-huh. It's assigned to something else. They're all just like variables
Okay.
of certain values and certain types. Variables of certain types holding values of that type.
This is not an array. Just reminds.
So here's the deal. All right, so this is a new video. But first I want you guys to practice, and then we'll answer your question
Okay.
about arrays versus slices. So I'm going to stop this video, and I'll put this code in. And I think for simplicity's sake, I'll take out the cowboy thing. And I'll just, well, do you like the cowboy thing in there? I'll leave it in. But what index out of range, because I was trying to access something here that no longer exists, right? Now it will run. There we go. So index out of range means I tried to access something at a position which wasn't there. Z only has one position. However, cowboy now has, I could do cowboy has 2 things in it. So I could do the second position and zero-based index. So the second position is 1, the first position is 0. And that will give me the 451 right there. All right, cool. So I want you to go to Golang Playground, and I want you to create a slice using the var syntax. Let me do a creative slice of string using the var syntax. Append to it your first name, append to it your last name, print it. Now I want you to create a slice of string of bool using the composite literal syntax. Append, put the values true, false, true into it, print it.